Hi everyone. So hope you all are keeping well. So the speaker for today's Tech Talk session is Rajitha Pathiraja. He will be speaking on designing serverless architectures on AWS, pros and cons. So over to Rajitha.
Thanks, Tina. Hi, good morning all. I'm Rajitha Pathiraja. I'm a certified cloud developer with 3 years of enterprise development experience. Mostly, I have worked with Amazon Web Services, and you can find me at rajithapathiraja.xic. Here you can see some of the recent projects that I have worked with. All these projects use many services in AWS. For an example, in million spaces, we use S3, Simple Storage Service, EC2, Elastic Compute Cloud, and SNS. It's a simple notification service. Also in Quora, we have used S3, EC2, SNS, and Route Tree, which is a domain name service for the AWS. So I'm currently working with the SQ team. SQ can be used as a case study to explain the serverless architecture. In this project, we have used AWS service architecture to get things done. And today, I'm going to show you why, how and what we can be achieved using a serverless architecture. So here's how I'm going to do it. The first question come to my mind when heard about the serverless is why we are going to use the serverless architecture. To understand that, I'm going to show you the benefits as well as the drawbacks of the serverless. So then you can come to the conclusion where you want to use the serverless architecture in your project or not. And keep in mind, it will depend on what kind of projects you are going to implement. So to explain the serverless architecture, I'm going to use Amazon Web Services. As you can see, Amazon Web Services are the leader in the market for cloud infrastructure. According to estimates from Synergy Research Group, Amazon market share is 33% in the fourth quarter of 2019. And also AWS has more than combined market share of its 3 largest competitors, which is Microsoft Azure, Google Cloud, and IBM Cloud. Also, AWS support for large organizations. For an example, Apple, Netflix, Twitch, LinkedIn, Facebook are some of the top AWS users. Also, AWS support the serverless computing. You can find out the more cloud market share by visiting this URL. So what is serverless computing really means? The architecture is designed in such a way that the developer doesn't need to worry about the server management or to plan capacity. Also, user write and deploy code without paying attention to the underlying infrastructure. These are the 3 main questions came to my mind when I heard about the serverless at first. The first thing is, does it mean that there are no servers at all? Or does it mean there are servers but you don't have to deal with them? Or does it mean something else? So here's my take on it. Serverless is about no maintenance. That means you can't completely remove the servers, but what you can remove is the need to worry about whether they are working or if they are up. Because if you don't have to care about the servers, you only have to care about how you use the services. The second point is serverless is an approach, not a technology. Serverless is more about the idea of removing the need to worry about the servers from the mix of things that you are going to do. So it will help if you know about server technology, but it is not necessary. So my third point is serverless is about micro functionalities. Serverless is about exposing individual functionalities rather than the whole server. It's about responding to an event and ignoring what underlying the technology is required. It's also about removing the need to manage uptime, server maintenance, upgrade, security vulnerability, etc. The only bit you need to is your code. That's all. So there are 2 architectures we can use in serverless. So when we speak about serverless computing, we mention architecture. First thing called as backend as a service. It's also called as a mobile backend as a service. The other thing is function as a service. For an example, best known vendor is which currently is AWS Lambda for function as a service. So let me explain what is backend as a service and the function as a service. Backend as a service. Initially, serverless computing had been depending on third-party cloud services, which allowed managing the server-side logic and state. These were typically a rich client application, such as single-page web apps or mobile apps that use cloud ecosystem, databases, authentication servers, and so on. Such types of services are described as mobile backend as a service. The idea underlying the BaaS is both web and mobile application requires a similar set of features on the backend, such as push notifications, server code, file management, social network integration, location services, and user management, etc. So, BaaS uses a unified API in SDK to manage the bridge between the backend and the front-end application. In this way, developers don't have to develop another backend for each services that the application use or access. So, for an example, AWS Amplifier and the Firebase are backend as a service. So, function as a service. Serverless computing can also mean application where serverless logic is written by the application developer, but it is run in the stateless compute containers that are event triggered and fully managed by the third party. This is the most popular way to think of is a function as a service. While in the microservice architecture, monolithic apps are broken down into smaller services. With FaaS, it goes even deeper and break apps into the level of events and functions. What this means is that you can upload modular chunks of functionalities into the cloud and they will be executed independently, splitting the server into a bunch of functions that can be scaled automatically and independently. So FaaS is the simplest and most obvious enabling technology for application using serverless approach. So AWS Lambda is one of the most popular implementation of function as a service platform at present. It is launched in 2014 by Amazon Web Services. AWS Lambda is an event-driven serverless computing platform. All the code executed in Lambda on the configured event trigger. That means instead of loading your application code into a virtual machine or container, you can upload it into a Lambda where it set domains until some external event triggers and the Lambda service bring you the app out of inactivity and execute it. I'll show this flow to explain the functionality of Lambda. First, you have to upload your code to AWS Lambda or written code in the Lambda code editor. Then set up your code to trigger from other AWS services or HTTP endpoints or activity. Then Lambda run your codes only when triggered, using only the compute resources needed. The best thing is about Lambda is you just have to pay for the compute time you use. So serverless computing does have many benefits, but like any other concept, it comes with significant trade-off inherent to that cannot be entirely fixed. So let's discuss one by one. The first thing is problems due to the third-party API system. Vendor control, multi-tenancy problems, vendor locking, and security concerns are some of the problems due to the use of third-party APIs. So I'll start with vendor control. Using third-party services means that you are handing over the control of some of your systems to third-party vendors. This entails the risks of system downtime, unexpected limits, cost changes, loss of functionality, forced API upgrade, etc. The second thing is multi-tenancy problems. That means where multiple instances of your software for several different customers are running on the same machine and possibly within the same hosting application, a number of problems may arise. Number one is security problems. For an example, one customer being able to see another customer data. The second is robustness. That means an error in the one customer software causing a failure in the another customer software, and there also can be performance problem. For an example, a high load customer can cause another customer to slow down. The third one is vendor locking. Whatever serverless feature you are using from one vendor will be implemented different by the other vendors. Therefore, if you want to switch vendors, you almost certainly need to update your operation tools and change your code than even your design or the architecture. The fourth one is security issues. It is obvious that using third-party services centralize the risks for the system security, and the number of security implementation increase, which is service vendor that you are using. So when using vast database from your mobile platform, you sacrifice the protective barrier of the server-side application. So another drawback of the serverless computing is lack of operation tools. That means the developers are depend on the vendors for debugging and monitoring tools. Also, debugging distributed system is difficult and usually require access to significant amount of relevant metrics and identify the root case. So architecture complexity. I'm gonna take a look at the AWS Lambda for an example. In AWS Lambda limits how many concurrent execution you can be running of all your Lambdas. The problem here is that is limited across your whole AWS account. For some organization, they use same AWS account for both production and testing. That means if someone somewhere in your organization does a new type of load test and start trying to execute thousands of concurrent Lambda functions, you will accidentally DOS your production application as well. Implementation drawbacks. Integration testing to a serverless application is tough. The unit of integration with the serverless parts are a lot smaller than with the other architectures, and therefore we are relying on the integration testing a lot more than we may do with the other architectures. Use also may occur problem related to deployment, versioning, and packaging, and also you may need to deploy fast artifacts separately for every function in your entire logical application. Another drawback of the serverless is latency. Serverless function means you have to deal with the call start. A very simple workaround that many serverless developers use is keeping function warm by hitting them at regular intervals. But this is the most effective for small functions. Things get more complicated when you have large function or relatively complex workflow. To minimize the call start, here are some things you should keep in mind. First thing is application architecture. So always keep your serverless function small and focused, because call start time increase linear with memory and code size, and also the language of choice. Comparatively, Python and Go can considerably lower call start time, whether C# and Java have the highest call start time. And the other thing is we can use GraphQL endpoint because GraphQL can provide the single endpoint to manage your entire service. Now I'll explain the benefits of the serverless computing. So there are no servers to manage, so it will eliminate the server maintenance, and also it is cost effectiveness. That's probably the main advantage and the main difference from the traditional cloud computing is that the customer doesn't pay for underutilized resources. The serverless computing service takes function as input, perform logic, returns your output, and then shut down. And the user is billed only for the resources used during this period. It significantly reduces cost by around 50 to 70%. Because you don't pay for idle. Then other benefits of the using serverless computing is simplify the scalability. It scales with demand automatically, so you don't need to worry about the scalability. It will handled by the AWS. Then other thing is automated high availability. This means the serverless computing provides built-in availability and fault tolerance. Therefore, developer don't need to architect for these capabilities since they are provided by default. Quicker turnaround. Serverless architecture can shorten time to market, as you can add and modify code without a complicated deployment process to roll out for bug fixes and new features. And it also reduces packaging and deployment complexity. That means all you need to do is pack your code and upload it. If you are just getting started, you don't even have to upload anything. You can write your code directly in the vendor's console. For me, a serverless solution can be identified in a relatively simple way. A serverless solution is one that costs you nothing to run if nobody is using it, excluding the data and the storage cost. So that means you simply don't pay for the idle servers anywhere. For an example, if you take this AWS-based serverless solution, you would have something like this: API gateway, Lambda, DynamoDB, S3, SNS, and Cognito. So if nobody was using the system, the resource would be essentially be domain name, and the data would be stored within your cloud-based system, ready for use at the first event. So you would be paying for the storage of the data, but not for the idle servers. While the system is always available, and remember that is not always on. So here are some companies using AWS in the production. You can see Netflix, T-Mobile, Coca-Cola, Guardian, right? For more information and the AWS side, they have some customer use studies. You can visit this URL to read about that. So let's see a use case of the SQ project. SQ team initially requirement is to build the application with minimum cost, better performance, and save DevOps time. So going serverless is the best option for them at that time. The survey that conducted by techpublic.com in 2019 find out that by going serverless way, you can save your cost about average of 65%, and you can improve the performance by 51%, and you can save the time by 50%. So AWS Server Platform contains 6 main types of services. So in our project, we have used almost every services that they offer in our serverless platform. For an example, we use AWS Lambda. For the API proxy, we use Amazon API Gateway. To store data, we use Amazon DynamoDB, which is a NoSQL database. For application integration, we use Amazon SNS, which is simple notification service, and Amazon SQS, which is simple query service. For orchestration, we use AWS step functions, and also to save static files, we use Amazon Simple Storage, which is known as S3. And we did the development in the serverless framework. It's a framework that gives you everything you need to deploy, development, monitor, and secure your server application on any cloud. It can be AWS, Azure, or Google Cloud. So let me summarize my presentation in one single sentence. As with all things in life, there are trade-offs. So serverless means you gain efficiency, and trade-off some control and visibility. So thank you for participation in the tech talk, and you can ask any question regarding serverless.
Thank you, Rajitha. So, any questions to be clarified?
Hi, Rajitha, Prashant here. What are the monitoring tools that you have used in the XQ project?
We use X-Ray. For AWS, we implement X-Ray for our project.
Okay. Did you find any specific practical issues when you are doing serverless compared to other serverful applications in SQ?
Yeah, by using DynamoDB, there are a lot of limitations compared to other NoSQL database such as MongoDB, like that. And the other thing is we have to deal with the call start. To prevent that situation, in our reporting module, we use GraphQL, so that GraphQL can provide a single endpoint. All the bits will get that to the endpoint, so we don't have to deal with the call start in that module.
Thank you, Rajitha, and it's been a great presentation, and hoping and contribute more in the future as well. Thank you.
Thank you, Prashant.
Okay, thank you, Rajitha. So, hope you all understood and found it interesting. So, this will be uploaded on social media. So, thank you everyone for taking part in this session. Hoping to have another Tech Talk session towards the end of this month. So, thank you everyone. Have a nice day.